So here we are. We're looking at my box drum, and today we can look inside of it and you can see what's going on in there. I have a magnet on the other side, and then spring runs into it every once in a while. But when I'm playing, I put it up on one end, and so the spring thing gummy is just in there banging into the wall, making metallic noises. And what we have here is some foil on top of a cardboard box with AuPd glue. Ye old Gorilla Glue, the original recipe, Gorilla Glue. And this is kaolinite clay, but the dust on the side of the road does the same thing. You screen the rocks out, and then you have a very fine dust or powder, and is mostly the stuff in here AuPd or AuPt. The gold colored dust is heavier than the white colored dust because there's more platinum in it. And so what we're doing today is just looking at this, and this is like what the original equipment box looked like, and that's what it sounds like. And when you close it up, it sounds like a fucking cardboard box, not a steel drum. And the difference, of course, is that I've got this glue on here, and it is now seriously hard. And I say goofy stuff like, it's got covalent bonds through the glue. And you think, well, how the hell does he know that, right? Okay. When AuPd crystallizes, it crystallizes in the cubic system, and it's face-centered cubic, which means there's a thing in the middle, and then like 6 things around it, 4 around this way and 1 on either side. You've got 6 things. Because it's like a box, right? Boxes have 6 sides. Sometimes boxes have one short axis. Sometimes they have a long axis, and a big tall box. Sometimes they're cubic. Okay, and that's kind of the foundation of what crystals do in crystallography, because 3-dimensional objects have 6 basic sides, right? Up, down, back, forth, and sideways to either side, right and left. So there's 6 directions, not 4 directions. 4 directions is a square, a plane. You would have 4 things like north, south, east, and west. Okay, but crystals form in 3 dimensions, and these dished out places here with the kind of lump in the middle. Those are hoppers. they're hoppers of the crystals of AuPd. Wow, huh? and sometimes they make innies, and sometimes they make outies. Wow, like belly buttons. Isn't that far out, huh? So what we have here is plastic, bioplastic from bamboo and AuPd, which is basically the dust on the side of the road. And it's so damn hard it crystallizes. And that's why it rings like a bell. Because the AuPd dust that I add self-assembles. It wants to stick together. It wants to arrange itself in cubic structure. And there's a magnetic element involved, okay, because it's AU and PD. And so there's gold has 79 protons and electrons. And palladium is down there right next door to silver in the periodic table. And I don't know what that is. I would have to look it up. But palladium has quite a few less protons and electrons. But they bond together with these covalent bonds because they form deep underground, not as molten metal. Okay? They're molten when they're coming up out of the earth, but when they crystallize, they cool down slowly underground rather than really quickly like we do with metals. And that's the difference. And so they create these covalent bonds rather than metallic bonds across the unit cells of AuPd or AuPt. And so this dust, man, you can't squash it, you can't break it, you can't squish it together. You know, if you took like flakes of gold, metallic gold, you mash them together and they'll, with a hammer, right? And it'll eventually go together if you smash it enough. It helps to heat it up, you know, but like I can melt gold really easy, and I can't melt this stuff, man, very easy at all. I have to get a really seriously hot torch to melt it. And the size of the particles of AuPd are down around 200 nanometers. One of the things they do is they break light into its component colors. Let's see if I can get a rainbow here. Maybe I better get closer. I've got too much glue on it. A little bit you can see. Anyway, it also changes kind of from gold to silvery colored as you move it. And you can see the cubic structure. The lines are not from the cardboard or aluminum foil, because aluminum foil doesn't have that. These are from the rows and columns of little cubes all lined up together. And they're sharing those covalent bonds across unit cells that are, which is the AuPd unit cells. So they're bound together, and they're slightly magnetic, each one of them, but they're all going in different directions, which means that it's not magnetic like iron would be, or something. aluminum is not magnetic, of course, and this stuff is something in between. It's called diamagnetic, and that means that it resists an applied magnetic field by creating an equal and opposite field. So if I try to land another magnet up here, this metal resists that stuff coming in. And what happens is, because the magnetic field is going around and around and around, is the metals here in the AuPd structure get a temporary direction from the round and round of the approaching magnetic field, and all of a sudden they become slightly magnetic, and you put that magnet down, and it'll just sit there, but it's not stuck to the thing, and these little guys will eventually, when the applied magnetic field goes away, they go away. They go back to being random. And that's what diamagnetic is. Okay? But it also means that because magnetism passes through this stuff, but it resists very, very little, because they're all going in different directions. And so what happens with my magnet in here is let's see if I can get this off of there. All right, let's see if I can make it stand up. There we go, see? And I'm not actually even touching the thing. See what I mean? The magnet's not touching the box at all, and I can manipulate the thing right through the box, my structural steel box, with magnetic stuff inside. So I could do, say, valves for an internal combustion engine or something. How about that? This stuff is a serious move in the right direction, because I can print an engine block basically out of cardboard and turn it into this stuff, and have an engine that doesn't weigh anything, that puts out 200 horsepower or something. Because it doesn't have a camshafts to worry about. I do the switching with the magnets for the valves. And it doesn't weigh anything because it doesn't have all that extra hardware. Wow, huh? Wow, man. And stuff doesn't wear out, whoa, that'll do that forever and ever and ever. Amen. It never wear out because it's not really touching anything, man. Just floating there. I've got my thumb between the and here's something cool, man. Your body is mostly carbon and water. Your body is a superconductor for magnetism, too. That's what makes it work. That's how come you can touch something and respond to what you're touching in real time. And people kind of see with their fingers. You pick something up to find out what it is. That's why we get that. It's the superconductor of magnetism. Because the stuff that holds the stuff together is magnetism. That's what holds everything together. Positive and negative charges and atoms. And that's what it is. And now you know what a superconductor is. It's not electricity passing. Electricity has to move from here to here to get over there. Magnetic field is already over there. It's already over there. Whoa, right to the bottom here. So if I have a pole on this side and a pole on this side, what happens on this side happens on this side at the same time. And that's how your nerves work. How about that? So I've been playing with radioactive stuff, and that's what that is. It's this dust on the side of the road that's collected into my joints and stuff from 40 years of research. So, it doesn't hurt, y'all. It just peel off. Looks bad, but it doesn't hurt. All right, so anyway. We've got a drum here. It's seriously hard. It rings like a bell now. Or a snare drum. It's got crystal structure. Waterproof because of the foil. I have some that's flame proof. You can put a torch on it like this. Uh-oh. Not this one. Whoops. Boy, I meant to do that. Okay. Anyway, here we go. This is AuPd. And it's probably going to change the world.